Hi, I'm Nick Raboy from Mongodb. In this tutorial, we're going to see how to create an in-game chat that's real-time using Mongodb and SocketIO. So basically what we're going to be doing is we're going to be creating a game. This particular game is going to be created with Phaser, and inside of our game, we're going to have a chat component. When users type into that chat component, the chats will be broadcasted to all other connected clients using SocketIO, and those messages will be stored in Mongodb. So that way anyone new who joins the chat will be able to see those chat messages and catch up to the overall conversation. So up on my screen, you'll notice that I do have Mongodb Atlas up, so the dashboard. We will be using it for this particular tutorial. You'll need to have already created proper application users as well as network rules prior to starting this tutorial. Now, our front end, being the game, as well as our back end, we'll be using JavaScript. So we'll be using Node.js for our backend and Phaser for our front end. We're going to start things off by working in our backend. So go ahead and open up an IDE or text editor. You'll notice that I am using Visual Studio Code. It doesn't matter what you use. So you'll notice that inside of my Visual Studio Code, I have two files. They're both images. They look like this. These will be used inside of this particular tutorial, but the actual image that you use does not matter. So within your IDE or within your browser or whatever you're using, go ahead and create a new directory to represent our backend. So what I'm going to say is I'm going to say make directory, and I'm going to call it backend. Now I'm also going to create another directory. I'm going to say make directory, and I'm going to say front end. If you're not familiar with the command line or you're not comfortable, go ahead and create those directories however you feel the most comfortable. We're going to take each of the two files and we're going to drag them into our front end directory. And we're not going to touch them for the time being. What we're going to do is we're going to be focusing on our back end first. So let's go ahead and create a new file. Let's go ahead and create a file called main.js. So I'm going to say touch, and I'm going to say, actually, before I say touch, I'm going to say cd, and I'm going to say backend. And I'm going to say touch main.js. Now I'm going to open up that main.js file, and this is where we're going to add all of our backend code, which is responsible for managing our sockets, as well as storing and retrieving data from our MongoDB database. Before we get started with actual writing of code, what we want to do is we want to initialize this directory as a new Node.js project. So I'm going to say npm init-y, and what that's going to do is it's going to create a package.json file within that directory. The next thing I want to do is I want to say npm install, and I want to say mongodb express cores and socket.io, and I'm going to say -- save. So it's going to install those dependencies as well as add them to our package.json file. At this point in time, we're ready to start writing our code. So let's go ahead and check it out. Let's go ahead and say constant express equals require express, and I'm going to initialize that using these parentheses as a constructor. I'm going to say constant cores equals require cores. So this will allow our game to communicate to our backend from a different port or a different host. We're going to say constant HTTP equals require HTTP, and we're going to say create server, and we're going to use express. We're going to say constant IO, so this is for SocketIO, and we're going to say require socket.io, and we're going to pass in the HTTP that we had created on line 3. Finally, what we want to do is we want to import our MongoDB client. So we're going to say constant Mongo client from, or actually equals, require, and we're going to say MongoDB. So we've just imported all of the dependencies that we had just downloaded. The next thing we want to do is we want to initialize our MongoDB client to use our actual MongoDB Atlas URL. So we're going to say constant client equals, and we're going to say new Mongo client. And what we can do here is we can either pass in an environment variable, some configuration file information, or we could actually just hard code our connection URL as a string. Now, my recommendation is to use environment variables because it'll help when it comes to security and you won't accidentally commit your URL to say GitHub with your username and password. but for this particular example, it's acceptable just to paste it in. And what we want to do is we want to go to our web browser and we want to find that URL. So I'm going to open up my web browser, and inside of Atlas, what I'm going to say is I'm going to say connect. I'm going to click on connect to my application, and I'm going to copy this string. I'm going to go back into Visual Studio Code and I'm going to paste it in. What I'm going to change here is I'm going to change the database that we're going to connect to. What I'm going to say is I want to connect to a database called GameDev. And it's all right if this database doesn't exist, because when we start executing commands against a collection, it'll create one for us. For the username, I've gone ahead and created an account called YouTube, and I've given it the following password. Now, this password and username that I have created, I set it to auto expire, so by the time that this video publishes, this user account will no longer exist. All right, so now that we have our Atlas URL, we can continue towards actually configuring MongoDB in our Node.js application and establishing some boilerplate around our SocketIO. So let's go ahead and say express.use, and we're going to say course. So we're telling Express that we're going to accept connections from different ports or different hosts. Next, we're going to say var collection, because even though that we are going to define our collection inside of our listener startup event, we want to use it within any of our endpoints or socket connections. I'm going to say http.listen. I'm going to listen on port 3000, and I'm going to make this an asynchronous function callback. Now, inside of this callback, this is where we're going to establish our connection to MongoDB. So I'm going to say try. If there was an error, I'm going to say catch, and I'm going to say console.error e. Otherwise, what we're going to try to do is we're going to say await, and we're going to say client.connect. Once we're connected, I'm going to say collection equals client.db gamedev dot collection, and I'm going to say chats. So again, your database and your collection, they don't need to exist prior to starting this tutorial. They can, but if they don't, and we try to create a document, or we try to read a document, they'll automatically be created for us. So we have our collection. The next thing we might want to do is we might want to print out a statement saying that we are connected. So we're going to say console.log. We're going to say listening on port, and I'm going to say maybe %s. And I'm going to say http.address, and I'm going to say port. And I could have easily hard-coded that, but at least when I do this right here, it'll take our port from our listen, so 3000. So I can save it. So we're listening, but we're not actually doing anything with the connections. And the listening is more in line with actually listening for socket connections, which we'll have listeners for, as well as if we make HTTP requests against our API, which we will do. So let's continue adding some boilerplate. Let's go ahead and say io.on and connection. So if a connection was established to this backend server, so if our game tries to establish a socket connection, what we're going to say is we're going to say socket. So we're going to get the handle of the socket that's being used. Now, once we do that, we can listen for other events that might come in from that socket. So I might say, for example, socket.on join, and I might do something with a join event. So maybe the user has sent a message with the message type of join, and maybe in our circumstance, they pass in a game ID, or maybe a room ID, something to signify that they're trying to join a particular game. So let's go ahead and call that game ID. And we're not going to populate it quite yet. Let's go ahead and do another listener. So let's go ahead and say socket.on, and let's go ahead and say message. And this is if the user has sent a message that they want to be broadcasted to other users on the server. So I'm going to say message. And likewise, we're not actually going to do anything quite yet. Now, if I wanted to, I could do other events to listen for. There's even some reserved words that we can use. But for this particular example, this is probably all that we need. We just want to know when somebody connects, when they've joined a certain room, and when they're trying to send a message. So let's go ahead and save it. Before we start populating each one of those listener events, let's go ahead and create our endpoint. So let's say, for example, that you have just joined a server. Maybe you want to get all of the messages that were previously sent on that server because you want to catch up. You don't want to come in with a blank slate. So our endpoint could be responsible for actually doing a find against MongoDB for any message that was stored. So let's go ahead and say express, and we can say get, and let's maybe call this chats. This will be an asynchronous function, so we're going to say async, and we're going to say request, response, and we're just going to leave it blank for now. Now, if we really wanted to, we could do all of this work inside of the connection event, and we could send this back to the user. But to keep our code very slick and organized, it really makes more sense to actually have this as a separate endpoint. We don't need this to be on a socket level. It's all right if it takes a little bit of time. So having a REST endpoint is perfectly fine for this example. So I'm going to save it. Let's go ahead and say that we want to actually obtain our messages. We're going to put our socket stuff on hold just for the temporary. Let's go ahead and retrieve documents from the database. So what I'm going to say is I'm going to say try. If there was an error, so I'm going to say catch, and what I'm going to say is I'm going to say response.status 500, and I'm going to say send. So we're just going to send a 500 error, and with that error we're going to say message, and we're going to say e.message, just to show the user that something bad has happened. Now, if there was no error, we can say something along the lines of let result equals await collection dot find one. So the reason why I'm doing find one is let's use the scenario that all of our messages for a particular game or a particular chat room will exist in an entire one single document. Now, it doesn't have to be that way. You could have one document per message if you really wanted to, or you can model this however you feel the most fit. But for this example, we're going to find one, and we're going to find it based on the ID of that document. So the ID might represent the actual game room. So we're going to say our filter is going to be based on ID. And for now, at least, let's go ahead and say that we are saying request.query.room. And this could be easily said as game or game ID. They're all going to mean roughly the same thing. We want to join some kind of game or chat room, so that way other users who are playing maybe different games or in different chat rooms, they won't be able to read our messages. Now, we won't have any kind of authentication in place for this example, but we could if we really wanted to. So let's say that we do our find one and we get a result. So we're going to say response.send, and we're going to send that result. And it's going to use a 200 code, so that's a success code. So we don't have any data inside of our database yet, so we can't really test out this chat's endpoint because no data is going to come back. So this is where it makes sense to actually start looking at our socket listeners. So starting with the join, so the flow of events, the user joins the game. They're going to say, you know what, I need to join this particular game ID. Let's go ahead and connect. Let's go ahead and say that we're joining. Let's go ahead and get our chats, and then let's go ahead and send messages. So it's basically going to go join, chats, message. So let's start with join. So because we're working with MongoDB, we do want to use another find operation. So we're going to say try, and we're going to say catch e, and we're going to say console.error, and we're going to say e. Now you could do other stuff. Maybe you send a response back to the user saying there was an error, but we're just going to print it to our backend logs for the sake of this example. Now, because we do plan to use a find one and we don't want to use then inside of our promises, let's go ahead and make this an asynchronous function as well. So on line 16, what we can do is we can say let result equals await collection dot find one, and we're going to search by an ID. So we're going to say ID, and we're going to search by whatever the user has provided us for the ID that they want to join. So we're going to say game ID because that matches what we have on line 14. Now the point of this is to either join a room that already exists or create a new room and join that instead. So we're first doing a search for if that room exists. So we're going to say if not equal result. So we're basically saying if the result comes back as null or undefined or similar, then we need to create that game room. So we're going to say await, we're going to say collection.insert1. And we're going to define our game ID. So we're going to say ID, and we're going to say game ID. We're also going to say that messages is going to be an empty array. Now, when this is all said and done, we're either going to have a game or we're going to have created a game. So let's go ahead and join it with our socket. So we're going to say socket.join, and we're going to say game ID. So that way our game or our particular socket that is sending this message has now joined on the server level this particular ID. Next, what we want to do is we want to emit a message back to the user or the game saying, hey, you've successfully joined this particular chat room. So I'm going to say socket.emit. We're just going to say joined. It could be really whatever you want. This is good enough to say that, we've joined this particular room back to the user and the user can listen for it. And we're going to send back the game ID that they had sent us. What we're also going to do is we're going to say our active room is going to be this particular game ID, because a socket can exist in many rooms. So you can join several different game IDs, but what we want to pay attention to is the active ID. So that way, all of our messages are only going to whatever they're active in. And you can modify this to meet your needs appropriately. So we're going to say socket.activeRoom equals game ID. And we're going to use that information to actually be able to determine what our active room is. All right, so we have the logic for creating or joining a game room by the ID. So now what we want to do is we want to be able to handle messages that come to and from the user. So let's go ahead and try it out. Let's go ahead and say collection.update1. And you'll notice I didn't make it an asynchronous function because at the end of the day, I don't really care what happens with the result. We can, it's totally up to you, but I'm just going to do kind of a push and then let it do its thing. So let's go ahead and say that we want to do an update. The filter criteria for this update one, for this one single document, will be based on the ID. So the ID has to match the socket.activeRoom. If there was a match, then what we can do is we can push our chat message into the messages array that we had created on line 18. So we can use the push operator. Now, push will just append a message. It doesn't matter if it's a duplicate or not. If you're looking to avoid duplicates, you might use the add to set operator instead. So for push, what I'm going to say is I'm going to say messages, and I'm going to say message. So the message that the user sends. Now, after this is done, what I'm going to do is I'm going to send the message to all recipients that are part of the active room. So I'm going to say io.to. I'm going to say socket.activeRoom, so it only sends to the people who are part of that room. And I'm going to say emit, and I'm going to say message. And I'm going to emit the message that was sent to us. So basically, our server is doing orchestration to all of the connected sockets, but it's also saving and grabbing our messages as they come in. So believe it or not, this should actually be done when it comes to our backend. It's not a whole lot. We have 2 different socket listeners, and we have 1 API endpoint. So what we can do now is we can actually focus on the game aspect of this particular tutorial. So let's go ahead and go back a directory and then into our front end directory. So this is where we're going to be doing all of our gaming related stuff. So I'm going to clear my terminal and I'm going to create a new file. I'm going to say touch index.html. Now again, if you're not comfortable with the command line, just go ahead and create an index.html file within your front end directory. Now what I'm going to do is I'm going to open up that index.html file. And we're going to start adding some boilerplate code, some HTML, and some phaser. So I'm going to say doc type. I'm going to say HTML, head, and then finally body. So what we want to do is we want to get both of the socket client library as well as the phaser client library. So that way we can make our game as well as communicate to our backend. So let's go into our web browser. And what I want to do is I want to search for SocketIO client CDN. And this is so that way I don't actually have to download SocketIO. It's totally up to you if you want to download it or not, but I'm going to go to a CDN and we're going to try to get the client version of that library. And I'm not sure this is what we're looking for, so let's go to a different site. You know what, it actually looks like it was correct. So let's go ahead and copy that code. If it doesn't work, we'll search for a different CDN to obtain our SocketIO client. So I'm going to copy it. I'm going to go back into my Visual Studio Code. I'm going to paste it in. It's good. Now what I'm going to do is I'm going to go back into my web browser and we're going to look for phaser. So we're going to click around. We're going to see how to download it should bring us to the CDN. So let's go ahead and copy the latest. We're going to get the min version. And I'm going to paste it into my Visual Studio Code. So I'm going to paste it in. So we now have the SocketIO client, or at least this should be the client version, as well as Phaser. So this is enough to get us started. Now what we can do is we can define where our Phaser game is going to be loaded. Because this is done after the page has rendered, we need a placeholder value to load our game into when the page is ready. So I'm going to say div, and I'm going to say ID equals game. The ID will be important in just a moment, and I'm going to close that off. I'm also going to create another script tag. And in here, this is where all of our game logic is going to be applied. So for example, I'm going to say constant phaser config equals, I'm going to say type, this is going to be phaser.auto. So basically our browser is going to determine whether or not we should be using WebGL or if we should be using an HTML canvas. The parent is going to be game, which is what we referenced on line 8. We have a width, which let's go ahead and make this 720p, so 1280, and then the height will be 720. We have maybe a background color. In this case, maybe I want my background color to be kind of a light shade of green. I actually wrote this down, but this is going to be hashtag E7F6EF. And then we're going to have our scene information. So scene is going to be init. So this is our lifecycle events of Phaser. So init is where we're going to initialize our variables. So I'm going to say maybe init scene. We have a create or a preload, which we'll maybe call preload scene, and then a create. So let's call it create scene. The naming convention is not too important, but this is what I'm using. Now, if we wanted to, we could also add an update, but we're not going to be using update for this particular tutorial. Now that we have our config, let's go ahead and create those methods. So init scene, preload scene, and create scene. So let's go ahead and say the following. Let's go ahead and say function init scene. We're going to have function preload scene. And then we're going to have function create scene. What we're also going to do is we're going to start that game. So we're going to start it up here. We're going to say constant game equals new phaser dot game, and then we're going to say phaser config. So essentially we have our configuration and we have each of the lifecycle methods that we're going to be using to actually add logic to our game. And these functions are going to communicate with our backend every time chat messages are made. So that way we can have a full chat experience within our actual game baked right in. So we're going to start things off with our init scene. So this is where we're going to initialize our variables. It's also going to be where we initialize where we're going to try to connect to when it comes to our SocketIO. So what I'm going to say is I'm going to say this.socket. So this is a member variable. I'm going to say equals IO, and I'm going to say HTTP localhost port 3000. And it's very important that we add the following as an option. We're going to say auto connect, and this is going to be false. We don't want to connect inside of the init scene. We just want to prepare it because we want to be able to connect and do something with the events rather than relying on when each of these lifecycle events is going to trigger. What we're also going to do is we're going to say this.chat messages equals empty array. So this is going to be where each of our chat messages flows in when we query our MongoDB backend. Perfect. So we have the initialization step done. Before we start looking at the preload and the create, we need to do an extra step. So we need to be able to get an input form into our Phaser game. To do that in Phaser, we actually have to create another file. So I'm going to say touch, and I'm going to say form.html. And this is inside of our front end. So this form will actually be consumed in Phaser, but we do need to create it first. So I'm going to say doc type, and it's just basic HTML. All right, so inside of our body, this is where we're going to say div And we're actually going to give it some CSS styling information. So I'm going to say ID equals input form. And inside of it, I'm going to say input. And I'm going to say type equals text. And I'm going to say name equals chat. And I'm going to say placeholder equals enter a message. Now, what's important here is the name part, the name attribute. So this is actually going to be used in Phaser when it comes to consuming data from this particular field. So it's very important that you have this. Now, because I said I wanted to style it, let's go ahead and add some styles. Let's go ahead and add the following. So I'm going to say style, and I'm going to say input form, and I'm going to say input. I'm going to give it some padding, and this is just to make it a little more exciting. So I'm going to say maybe 10 pixel padding. I'm going to say font size is going to be maybe 20 pixels. And I'm going to say the width is going to be maybe 250 pixels. And we could always modify that depending on what everything looks like. So now that we have our form, now what we want to do is we want to add it to our actual Phaser game. So go back to the index.html file. We needed to add some things to our Phaser config object. So we actually want to say DOM, and it doesn't really matter where you add it in this object, but we want to say create container, and we want to say true. So this will allow us to use DOM elements within our Phaser game. So with that available to us, now we can go to the preload scene. And inside the preload scene, we can say this.load.html, and we can give it a name to be used within Phaser. Doesn't really matter the name. And we could also supply the file that goes with this particular name. So we can say form.html. The name does not need to match the file. So I'm going to save it. So in theory, we're able to now use this particular form item, but it's not immediately displayed on the screen. So we need to add it. And this can be done inside of the create scene function. So let's go ahead and do the following. Let's go ahead and say this.textInput equals this.add.dom. We need to provide it a position. So let's say that we want it to appear on maybe the far right of the game canvas. So we're going to say maybe 1135. Because remember, we're using 1280 by 720 as our dimensions. And then as far as the Y position, maybe 690. And we're going to say create from cache. And we're going to say form, because that's what we gave the name on line 35. Now, because we want to position it from the center point and not from the corner of this particular form element, we're going to set the origin, and we're going to say set origin is equal to 0.5. So that's the center point. You can have a value between 0 and 1. Now what we want to do is we want to have an area so where we can actually display our chat conversation. So the text input is going to be where we collect it, but we want to also display it. So what we can say is this.chat equals this.add.text. We need to give it a position for this particular chat box, maybe 1000 in the X and then maybe 10 in the Y. At the start, it's going to have no text in it, but maybe we want to have some style information for this particular text element. So maybe we say that the line spacing is maybe 15. Maybe we say that the background color is a hexadecimal value, which I've also written down. It's going to be a shade of like gray. But we're going to say 21313C, and we're also going to give it a factor of transparency. So I'm going to say DD, and it's not too transparent, but it's not 100% solid. Next, maybe what we're going to do is we're going to say that we want to have a text color. So I'm going to say color, and I've written this down again. This will be a shade of green, but we're going to say 26924F. And I noticed that instead of background, it should actually be background color. Finally, let's go ahead and add some padding and some font styling. So I'm going to say padding, let's go ahead and say maybe 10, so that way it's not at the edge of the text box. And for the font style, so that way it's a little more readable, let's go ahead and say that it's bold. And I'm going to save it. So now we have our text input as well as where our chat will end up. So we're going to submit this particular chat box when somebody hits enter. So what we want to do is we want to listen for the enter key event. We want our game to be able to consume the enter key. So let's go ahead and add to it. Let's go ahead and say this.enter key equals this.input.keyboard phaser.addKey. And the key that we want to add, we want to say phaser.input.keyboard.keycodes.enter. So now we're actually listening for that particular key. Now, what do we want to do when that key is pressed? So let's handle that. Let's go ahead and say this.enterKey.on, a down event. And if there was a down event, let's do some magic. But before we even get to the keyboard aspect of things, we probably want to connect to SocketIO. So we probably want to connect to our backend, because on line 30, we've specified not to auto connect. So we're not going to actually be able to send a message until we've first connected. So let's go ahead and look at the next stage of our code. So we'll come back to the enter key. All it's really going to do is it's going to send messages. Let's go ahead and say this.socket.connect. So this is where we're actually going to establish a connection. Now, if the connection happened, we're going to say this.socket.on connect, and we're going to say async, and we're going to say what's going to happen with this callback. Well, we probably want to emit a join event. So we're going to say this.socket.emit, and we're just going to say that we want to join the MongoDB game. So we're actually hard coding this particular game room. We're not going to let somebody choose for this example. But when we've established a connection to our SocketIO server, our backend, so we're going to send this join payload. Our join event is going to trigger, and we're going to first see if that game exists based on the ID. If it doesn't, we're going to create it, and then we're going to set the active room to MongoDB. So that's basically what's going to happen. All right, so we've tried to connect. Now let's figure out what happens when we've actually joined. So we're going to say this.socket.on joined, because remember our server is going to send a join back to the socket. We're going to say async, and we're going to say game ID, because that's what the server is going to send back to us. Now, if we joined, what we can do is we can say let result equals await, and this is where we're actually going to make an HTTP request to our RESTful API endpoint for chats. So we're going to say fetch. I'm going to use a backtick character, but I'm going to say HTTP localhost 3000/chats. Actually, I'm going to say $room equals, and I'm going to say game ID. So what the server has sent back to us. After we get our response, what we want to do is we want to convert it to JSON. So we're going to say response.json, and then technically we could do something with the result. So in this case, we want to populate our chat area of the screen, so our text, with the chat messages. So to do that, let's go ahead and say this.chatMessages, remember it's an array, equals result.messages. After we do that, let's go ahead and say to the user, welcome to the room. So we're going to say this.chatMessages.push, and we're going to say welcome to, and then maybe game ID. All right, so we're letting the user know that they've joined. We're going to have a finite amount of chat messages in our chat box. We don't want to implement scrolling for this particular example. You could very easily do that on your own, but for this example, we don't want to implement scrolling. So we need to check to see if our chat array has exceeded a certain size. So I'm going to say if this.chatMessages.length is greater than 20. So if that array has more than 20, what we're going to do is we're going to say this.chatMessages.shift. And what that's going to do is it's going to remove the top item from that array. So whatever is at index 0. So it's going to make it look like the chat is scrolling up, but it's just going to be removing items from our local chat. After we've removed potentially our message, let's go ahead and actually set that chat. So I'm going to say this.chat.setText, and I'm going to say this.chatMessages. So when it comes to phaser, when you have an array, it's basically going to separate each array element with a new line character. So we don't have to worry about adding new line characters if we're using an array. So it's going to create a very attractive looking chat for us. So that's what happens if we have joined. Now let's go back to our key event on line 50. So let's go ahead and say that we've joined, we've connected, now we want to send messages. So inside of our down event, let's go ahead and say let chatbox equals this.text input dot get child by name. So this is where that name attribute comes into play when it comes to that form.html file. So remember, we called the name attribute chat. So that's where we're obtaining it. So once we have that particular input field, the chat input field, what we can do is we can say if chatbox.value is not equal to empty character, so there's actually something in the chat box when the enter key is pressed, we can say this.socket.emit, and we can say message, and we can say chatbox.value. And then finally, what we would want to do is we would want to clear that chat box. So we'd say chatbox.value equals empty string. So in theory, we have now sent a message to our server, and we're not actually listening for messages. So we're sending it. We're not adding it directly to our chat field or our list of messages. We're only doing that when we first join. So we need a way to listen for any messages that comes from the server. So let's go ahead and add another event listener. Let's go ahead and say this.socket.on message, and we're going to say whatever that message was that came through the pipeline. Now we're going to say this.chat messages. We're going to say push message. We're going to do the same logic that we saw above. So we're going to copy it and we're going to paste it in. So with the message, anytime a new message comes in, we're going to push it to the array, and then we're going to check to see if we've exceeded our quota of 20 messages. If so, we're going to remove the element 0 and we're going to render them to the screen. So let's go ahead and test our application to see where we stand. So what I'm going to do is I'm going to split my terminal here. I'm going to go back a directory for our back end. And I am in the front end. So it's actually in the other terminal, I'm going to say CD and I'm going to say front end. So one terminal has the front end, one terminal has the back end. I'm going to say node main.js on the back end. And for the front end, you will need to be using a software that is able to serve your HTML file. You cannot just open your game from the file system. It won't work. So some recommendations are you could use Python to do this. I actually installed a package called serve. So if you wanted to, you can say npm install gserve. So that will actually serve the application as well. And that's what I'm going to use. So I'm going to say serve. It's going to serve our index.html file. What I'm going to do is I'm going to go to the browser. I'm going to open up a new tab. I'm going to say localhost port 5000. So as you can see, it's a black screen. It actually looks like maybe my color didn't take. Let's go ahead and look at the logs. That's interesting, but it did say welcome to MongoDB, which is great. I will revisit the color situation in just a second. Let's go ahead and say hello world. I hit enter. So it added the message. Now in theory, if I went to my clusters within MongoDB and I went to collections, I can click on game dev, I can click on chats, and you'll notice I have an ID called MongoDB, and I look at my array and I have hello world. So that's the message that I sent. So let's go ahead and see why our rendering is a little off. So let's scroll up on our index.html and let's look at our background. So what we probably want is we probably want background color. So I'm going to save it. I'm going to go back to the browser. I'm going to refresh. When I refresh, it should show hello world because that's what we have in our database. When we join a room, we do a fetch and we get every message that's in that particular document. So let's go ahead and try it out. It looks like it worked. So we now have a greenish color and we have a background to our text messages, but I think we could do better. So what we probably want to do is we probably want to define how much space that particular text area takes. So let's go into our editor. Let's go to where we created our text and let's go ahead and add the following. Let's go ahead and say this.chat.set fixed size. And you know what? Let's go ahead and say that it is 270 in width and maybe 645 in height. So I'm going to save it and I'm going to go back and refresh. So it looks a little more appealing now. It says hello world because that's our kind of history of messages, and then it says MongoDB. That was done on purpose because we want to first show all of the messages that happened prior to joining, and then we want to say, hey, welcome to the chat room. We're not quite done yet. Even though this is great, it's not too attractive because, again, this is supposed to be a game. And we could easily do a normal chat window like this in any old HTML. So let's add our images to this game. Let's make it a little more exciting, a little bit more interesting to work with. So let's go back into our code. Let's go to the preload scene. We want to load one of those media assets. So let's go ahead and say this.load, and we're going to say image, and I'm going to say maybe nraboy, so my picture. And I'm going to say nraboy.jpg. So we have our image asset to work with. Let's go ahead and add it to the create scene. We can add it towards the top. It doesn't really matter. Let's go ahead and say this dot, I don't know, sprite group equals this. And we want to use physics. Oh, actually, let's not use physics to start. Let's go ahead and say this.add.group. And let's go ahead and say that our options for this particular group, the default key will be nraboy, and the max size for our object pool, this is an object pool group, is maybe 15. So we're going to have this stuff move around on the screen in just a second. So if I show this right now, it won't necessarily do anything because there's I'm creating the group, but I'm not actually loading it. So let's go ahead and loop through that group. We're going to say for, we're going to say let I equals 0. I is less than 15, I plus plus. Let's go ahead and say let, and we're going to create random x and y's for each of these images. We're going to say random x equals math.floor, and then math.random, and anywhere between 0 and 1000. We're going to do the same thing for the y position, and this is going to be because we're doing 1280 by 720. Let's go ahead and say maybe 600. And let's go ahead and say this dot sprite group dot get random x, random y, and technically this would work. But if I save it and I reload, we're going to have some very large images, I think. So let's refresh. Yeah, a bunch of random, very large images. So let's fix this. Let's go ahead and make it scaled properly. Let's go ahead and say set scale. Let's say that maybe it's 0.2. We're going to save it. We're going to refresh it. So there's a bunch of images around the screen. Fantastic. All right. So let's go ahead and make them move around. To make them move around, we're going to need to add physics, but with Phaser, it's actually not that hard. So let's go ahead and open up our editor. We're going to go back to the Phaser configuration towards the top, and we're going to add the following. We're going to say physics, and we're going to say default is going to be arcade. So arcade physics. Phaser offers a few different versions of physics. And we're going to say arcade. And we're going to say gravity is going to be in the y direction. And it's going to be 200 as the value for gravity. But we also need to make an adjustment with our actual sprite group when we loop through it. So what we can do is we can say the following. Whoops. We can say dot set velocity, and we can say maybe 100, 200. So that's the x and the y velocity. We can also say that we want it to bounce when it hits something. So 1 and 1. And we want to say that if it collides with the edges of the screen, this is where the collision should happen. So we should say set collide world bounds, and that's going to be true. Let's go ahead and see where we stand. So it doesn't look like anything is happening yet. Let's go ahead and look at our logs, make sure we didn't make an error. So set velocity, let's see. Oh, because we're trying to use physics on a non-physics sprite group. So let's go ahead and go back into our code. And instead of saying this.add.group, I'm going to say this.physics.add.group. And that should fix it. I'm going to refresh. Bam. It didn't bounce around, which is not great because set bound, it's obviously a typo here. So let's go ahead and fix that. Should be set bounds, plural. So I'm going to save it. So it should bounce, hopefully. Nope. Let's see here. Set bounds is not a function. Oh, set bounds. All right, I made another mistake. So let's go ahead and fix that. It's not set bounds. It's going to be set bounce. There we go. Let's go ahead and go back into the browser. So see how they're all bouncing around? They're all bouncing around in the same direction at the same speed. So maybe we can fix that, maybe clean it up a bit. Let's go back into our editor. Let's go ahead and add another random value here. Let's go ahead and say let random velocity x equals math.floor math.random times 2. So 2 different variations that we can do. And then for the x, let's use an array. So our array values, our 2 elements could be maybe negative 100 and positive 100. And we're just going to apply the random velocity in here. So now, whatever the random value is, it's either going to choose negative 100 or 100 for the x and then 200 for the y. So let's go ahead and check it out. Looks not bad, but the images are floating on top of the chat box, which we don't necessarily want. So we should be able to set the depth instead. So let's go ahead and go up. Let's go ahead and say that this.chat.setDepth is maybe 1. So it should be, this is like the Z index. So let's go ahead and refresh. And now it's behind. So this is all very good stuff. And if I wanted to, I could open up another browser tab. Let's see if I can pull it out. Let's go ahead and go to the site here. So let's go ahead and say localhost 5000. We have our messages. And let's go ahead and say woot woot. And you can see that on this other window, the message was almost instant in loading in that chat. And if we go back to Mongodb Atlas and we refresh, and if we look at our array, we'll notice that we have hello world and woot woot. So everything seems to have worked as planned. So in this particular example, we saw how to use SocketIO and Phaser with MongoDB. So SocketIO was responsible for orchestrating our messages. They were saved into MongoDB, and they were loaded or saved depending on what the user was trying to do. And this was done using a Phaser game. Now, you don't have to use Phaser, but this was a gaming example, so it made a lot of sense. So there are other things that you could do when it comes to SocketIO and your games, but this is just one of many possible scenarios, which makes, in my opinion, a very exciting example.